Now we're going to talk about something called inverses. We're going to talk about how to find it from a list of points, from a graph, from an equation, and how to prove that two equations are inverses. If we have a list of points, what we're going to do is switch every x and y values. So my new table that represents the inverse would be switch your first x and y, so it would be 5, 1. If you have 2, 6, that means my inverse is 6, 2. If I have 3, 7, then my inverse would be 7, 3. And if I have an inverse of, or I have a 4, 8, that means I would have 8, 4. I could also list these as a set of points. So my original is the set of 1, 5, 2, 6, 3, 7, and 4, 8. And my inverse is just all those points reversed. Notice they're just the points from my table. So graphically, I'm going to do the same thing. Switch every x and y. But there's something else special. The graph of the inverse is always a reflection of the original graph over the line y equals x. Let's see how this works. So if I have 0, 0, if I flip x and y, I'll have 0, 0. That was profound. If I have the point 2, 2, and sorry my graph is a little bit squished, then the new point will be 2, 2. Okay, so those ones are a little boring. But how about we look at this one? Then 0, 5 will become 5, 0. Over here, negative 2, negative 1 would become negative 1, negative 2. And this last one, positive 4, negative 3, would become negative 3, positive 4. And if I draw the line y equals x here, you'll see that things basically traded places over the line. And if it was on the line, it stayed. So that 0, 0, and 2, 2, they stayed on my line. But everything else flipped from one side of the line to the other. Okay, let's look at equations. When we're looking at equations, we want to look at our original. So in equation, replace x with y and y with x. So we're basically going to do in a notation way what we've been doing graphically or with points. And typically, as per usual, we will solve the new equation for y. So let's see how this works. So if my original is y equals x minus 4, my first step is to reverse x and y. And now I need to solve for y. So how would I usually solve for y there? I would add 4. So my inverse is, I'm sorry, that was so sloppy, y equals x plus 4. In the next one, I would have 2y minus 3x equals 4. So then to get y by itself, I would add 3x to both sides, which can't combine, and gives me 2y equals 3x plus 4. And then divide by 2, and I would get my inverse, and I'm just going to abbreviate that, would be y equals 3 over 2x plus 4 divided by 2 is 2. Here's something a little bit different. Still start the same way. So x equals the cube root of y minus 4. So then, this is what we've been doing lately. To undo a radical, I would cube both sides since it's a cube root. And I'll just leave that as x cubed equals, my radical cancels with the cube, so y minus 4. And now, just like the first problem, I need to add 4 to both sides. So my inverse would be y equals x cubed plus 4. Once again, that's my inverse. Okay, the last thing might be a little bit new. So what we want to think of, if we put g of x into f of x, and it's an inverse, I should get, when I simplify, x as my answer. And the same thing should happen if I put f of x into g of x. So I'm going to use some color coding here to help. And I'm going to say that f of x is red and g of x is blue. So in my first one, it's saying that I need to plug my blue function into my red function. So instead of writing an x, I'm going to write g of x. So my original equation is 2x minus 4. But I want to think of it as 2 times something minus 4. That's all that x means, is something. It's just representing kind of a space. And now in that space, I'm going to put g of x. So let me make my pen a little bit smaller. 1/2 x plus 2. And now I'm going to simplify. So 1/2 x times 2 would be x. 2 times 2 would be 4. And watch what happens. 4 minus 4 is 0. So we would say f of g of x. Oops, sorry. I meant 4 minus 4 is 0, which is true. Means my answer would simplify to x. So it works that way. Now let's try putting our red function into the blue function. So if I write what I like to call the structure of the problem, the structure of g of x is 1/2 times something plus 2. And in this case, the something I'm going to put in here is 2x minus 4. And now I do the same thing, distribute. 1/2 times 2x would be x. 1/2 times negative 4 would be negative 2. And I have this plus 2 hanging out. And those are going to reduce to 0, so my final answer is, once again, x. So my conclusion would be, yes, they are inverses. That's it. Be ready to come in and practice tomorrow. Answer the questions at the bottom.